Today we're going to talk about classes and objects. And this is a pretty big topic, so we'll look at it in a couple sections. My guess is I'll put together a total of 3 or 4 videos that will cover this very, very important topic. Today we're just going to look at some terms, some terminology, some definitions, and some big ideas. We won't actually get into any of the Java code in this video, but I'll put out the next video where I'll actually show you how to write classes in Java. So again, today is just about understanding the ideas behind classes and objects. And I should say that classes and objects are vitally important to computer science in general. When we start getting into writing our own classes, we're moving away from just the basic procedural code that we've written in the past, and we're getting into what is called object-oriented programming. Object-oriented programming is really the foundation of almost every program that you probably interact with right now, whether it's an app on your phone or a program on your laptop or just about anything. It's written using what is the idea or what is called object-oriented programming, where we're not just writing individual lines of code, but we're creating classes and then creating objects from those classes, and those objects will do things in our application. So let's get into it. Again, this is a new idea. It's a big idea. It's a super important idea, and I think and know that it's something that we can all do and understand well. All right, so let's get moving. First term that we want to look at is the idea of a class. A class is a blueprint for creating objects. So this blueprint includes attributes or instance variables and methods that the created objects all share. So we'll come back and explain this better in just a moment, but let's look at our next term because the two terms are very much related to each other. The second term is an object. Objects are entities in your program that you manipulate by invoking methods, and you'll hear me use the words instance of a class. So objects are instances of a class. If you create a class, you then create an object, and an object is kind of like an example of that class. You'll also hear me use the word instantiate. When you create an object, I'll say you instantiate an object. That's just the same, I guess, a different word for the same idea. So those are the terms themselves, but what do I mean by them? Well, if we go back to the idea of a class being a blueprint, I like to think often of, well, if you have a house, and well, we all have something that we're living in, right? Before they could build the house, there had to be a architect that sat down and designed a blueprint for your house. Or perhaps we could think of Lower Merion High School, right? Before they could build Lower Merion High School, I think about 10 years ago now at this point, somebody had to sit down, or a bunch of somebodies, and draw a blueprint. The blueprint would be looked at, studied, edited, modified. Once they were all good with it, they had this big piece of paper, or a bunch of pieces of paper, a computer screen somewhere that had a blueprint for our high school. Now, you couldn't actually do anything with this blueprint. You couldn't go to school with the blueprint. You couldn't do much of anything with it other than look at it, because it was nothing more than a blueprint or the instructions for building our high school. So again, a class is just kind of like this blueprint. You can't actually do anything just with the class itself. It just describes how you could create an object. Now, the object in this example would be our actual high school, right? Lower Merion High School, they took the blueprints, they hired a bunch of construction workers. The construction workers built our high school using the blueprints. So we could say that our high school is an instance of the blueprints. We could say when they built our high school, they instantiated, although that sounds kind of weird. I guess the other takeaway could be they could take those blueprints and they could build 100 Lower Merion high schools. They could bulldoze half of Lower Merion and just build high schools all over the place. They could all look the same. They would all be instances of that same class or that same blueprint. And that's what you'll see we'll do in Java, not bulldoze anything, but we'll create a class, and then from that class, we'll create a bunch of different instances. So, well, I won't go on anymore with this idea. Let's look at a different example now. So, my favorite game, perhaps all time, is Super Mario Brothers. So when the authors of this great game sat down and started writing. They didn't just start writing lines of code and lines of code. Instead, they would have designed a series of classes. And let's describe what the class could have potentially looked like for Mario. Now, every single class that we're going to write has two basic pieces. The first we'll call characteristics. And a characteristic, I think, is pretty self-explanatory. It's just a trait, it's an attribute, it's something that describes your object. The other thing that we'll have to write when we create classes are actions. Actions are things that an object can do. Right? Now, you'll hear me refer to characteristics as properties. I'll also refer to them as instance fields. And finally, you'll hear me refer to them as instance variables. These are all names for the same idea, characteristics, traits. And really, every object that exists has characteristics, right? If we were to think about us, individuals, people all have characteristics, whether it's hair color, or I should say even do we have hair, eye color, height, weight, ethnicity, right? Every single person is going to have, I guess, the same list of characteristics, but we'd all have our own values for these characteristics. My eye color is probably different than your eye color. My hair is a little grayer than your hair is, but we all have these characteristics. The actions we'll call methods, right? Actions are things that we can do. Again, if we were to think about it as people, everybody can do basically the same things, right? Everybody can walk, talk, think. We all do it a bit differently, though, right? Everybody's voice sounds a bit different. Everybody's walk is a bit different, right? You get the idea, right? So again, when we create a class, we're going to create a list of characteristics or things that describe the object or will describe instances of that class. And then we're going to create a list of methods or actions, which are things that the object, or again, instances of your class, will be able to do. So if we were to get back to our Mario example, what are some things or characteristics, I should say, that we might want to include in our Mario class? Well, for me, I think we'd probably want to have an image or a series of images that we would use to display Mario on the screen. We might want to keep track of how many lives Mario has left. Perhaps a location on the screen. Where is he? Where should we draw him? I guess on the actual physical screen or in the world that he's currently navigating through. How fast is he going? So maybe we need some sort of speed property. What direction is he going? Left or right? Jumping up, down? And then this one's a little less obvious or perhaps necessary, but invincible, right? When he hits that star, he can't die, he goes faster, and all that good stuff. So that's just a short list of characteristics that Mario might have, but yeah, gives us an idea. All right, the next thing that I've already said that we'll need to write are actions, things that Mario can do. Now, we've been writing methods for a while now. We know how to write methods. That's not new. But what is new with regards to writing classes is whenever we write a method in a class, we want that method to directly modify or perhaps get information about one of our object's characteristics. So what do I mean by that? Well, by example, perhaps we have a method called die. That's a bit morbid, but I think you can see if we were to have Mario die in the game, it's going to change a couple of Mario's properties. Would it change the image? Yeah, I think so, right? When Mario dies, I think his image looks different. Would it change the number of lives that he has left? Yeah, obviously, right? That will go down by 1. Will it change his location? I don't know about that. Would it change his speed? Yeah, I mean, if he was moving, he's going to stop altogether, and the same perhaps with direction. You get the idea, right? If we were to call this die method, we're going to change a series or a couple of his characteristics. Here's another example. Perhaps we have a method called run. So whenever we want Mario to run across the screen, we're going to call this method. What characteristics would run change? Well, clearly its location, perhaps its speed, perhaps its direction as well, depending on how you implemented that method. Okay, here's the last example of a method. and that would be hit star. And this one again is maybe not, I don't know, quite as essential as the others, but still communicates the idea behind a method and what it will do. So here, if Mario was to hit a star, we know that a star and Mario, what makes him invincible. So this property of whether or not Mario is invincible would clearly have to change. I think his speed changes because when you hit a star, the character always speeds up. All right. So those are the two main pieces or parts that we're going to write when we create a class. There's one last piece that I haven't mentioned. I'll mention that now, and that is a constructor. A constructor is really kind of what its name sounds like. It's how we construct or make or build an instance of our class. So it's the method that we'll call when we want to create an instance of our class, when we want to create an object. And a constructor is basically just going to go through and set values for all of the properties that we have in our class. So those are really the three things that we'll be writing. Constructors first, then we'll list characteristics that our class will have, and finally we'll write a bunch of methods or things, actions that our character can do. Now, this example is almost done. I promise I'll move on in just a moment. But if I was to write this class, what would I probably call this class? Well, I said Mario just a moment or two ago, but I don't think that's really the best name. I'd probably call this something like Hero. Why would I call it Hero instead of Mario? Well, because we might want to create different instances of this hero class. For example, we might, obviously create a Mario, but we could also create a Luigi. Now, Luigi would be or could be another instance of this class where he's still going to have the same characteristics, right? He has an image just like Mario has an image. What's the difference? Well, it's a different image. He's probably going to have the same numbers of lives. He's going to be drawn somewhere else on the screen. You get the idea, right? He's going to have his own characteristics. They just might vary. I mean, what is being characterized will be the same. I just say the values themselves might be different. He's going to be able to do the same things. He can die, he can run, he can hit a star, right? So again, I would name this class something like Hero, and then we could go through and we could create actual instances of that hero class and call them, well, whatever we'd like. And if we were to go beyond that, obviously you could create like a princess character or hero, Toad. I forget the other Mario characters at the moment, but there it is. All right, just two more quick slides and I'll be done. And the first term that we want to look at is interface. So when you create classes, there are really just two more terms that we need to be familiar with, and they're kind of, I don't know if opposites is the right word, but they're kind of opposites of each other. I'm going to use it even if it's not 100% correct, right? So an interface are the messages of an object that you can call. So really what an interface is what you see from the outside looking in at the class. I'm a little nervous that my graphics here might be incorrect, but let's see what happens. Yeah, that's wrong. I apologize. So it's not inside the class that we're dealing with, right? An interface is what you see looking in from the outside. So when you talk about the interface, you don't care or necessarily know how any of the code is written inside the class. You don't care. You don't know, and you don't care that you don't know. It's just what you see looking in from the outside. So the interface is all the pieces of a class that you see from the outside of a class. The interface is what allows you to work with a class or to create and modify objects or instances of that class. So again, the first term here is interface. It's what we see looking in from the outside. It's how we interact with an object. The other term is implementation. And the implementation is what is inside. So interface, looking out in. Implementation is what is actually inside. It's the code inside your class that will make your class work. So it's where we'll be spending the majority of our time. On the next video, we'll learn how to write the actual implementation for a class. All right, so that's it. Again, I'll be posting more videos on classes. This was just meant to be an introduction. I hope it gives you at least an idea about what a class is.